Percival Lowell was on an urgent mission for astronomy. Percival Lowell, one of the Lowells of Massachusetts, one of the forever wealthy, Harvard-educated, a brilliant mathematician. Lowell was headed west on a mission he had created, a mission he was paying for, a mission he had assigned to himself. As his train steamed west across the face of planet Earth, 62.5 million miles away, the planet Mars was rushing towards Percival Lowell. Mars would soon be in opposition, the closest it comes to Earth, an opportune time for Lowell to fulfill his mission, to find life on the mysterious red planet. Earlier that winter, Lowell had dispatched an assistant to Arizona Territory. His orders, to find the best place for seeing, a term astronomers still use to describe the clarity of the atmosphere. From the clear mountain air of Flagstaff, the assistant wired home for the 11th time. This was it. Percival Lowell had found his spot. Lowell talked Harvard University into lending him a telescope, which he promptly had shipped to the Arizona frontier. During that summer of 1894, the eager amateur indulged his obsession, learning the night sky, drawing over 1,000 sketches of Mars.
Mars is not a dead body. On the contrary, its features are in a continual state of change. The appearance of the planet does not remain the same day after day, or even hour after hour.
The wealthy Easterner charmed the people of Flagstaff, so they gave him 5 acres of land above town. He named it Mars Hill. The pioneering townsfolk hoped Lowell's observatory would bring them riches and renown. What the observatory did attract was more pioneers. Pioneers of space and time. (1994), 100 years of seeing. It has been a momentous century for astronomy. A new planet discovered, the origin of the universe, the Big Bang Theory proposed, men bounding across the surface of the moon, a cosmic collision witnessed for the first time in recorded history. The Lowell Observatory has played a direct role in many of those events, so its 100th birthday was cause for celebration. Much of the talk was about the century's biggest show in the solar system, a comet crashing into Jupiter.
We know there are northern lights on Jupiter, but these are very special.
Among those present were the comet's co-discoverers, Gene and Caroline Shoemaker. Gene worked until recently for the U.S. Geological Survey and has now joined the staff at Lowell.
Well, Lowell is a very special place. You have great freedom to carry out scientific research so long as the funds can be found for it. And it has a tradition, of course, from the very beginning of a focus in planetary science. So it carries on a tradition that goes all the way back 100 years to its founding with Percival Lowell.
From the very beginning, Percival Lowell gave more than money to the observatory that bears his name. He gave his soul, and his passion for the stars and the planets.
Wait till the sun sinks behind the hills. Then, as half-light deepens, the universe appears, and one by one the company of heaven stand forth to human sight. If night discloses glimpses of the great beyond, knowledge invests it with a meaning, unfolding and extending as acquaintance grows.
Lowell's enthusiasm did not endear him to the astronomical community. Many were appalled by his theories about Mars. They dismissed him as a crank, nothing more than a meddling aristocrat. Over time, the scientific world has changed its tune. Leading astronomer Carl Sagan.
If Lowell Observatory hadn't been founded, then a whole set of important discoveries, the expansion of the universe, the discovery of Pluto, the early measurements of the temperatures of planets, the setting of the stage for the survey of white dwarfs through the galaxy, the most common end state in the evolution of stars, all that would not have been done. So however grumpy you want to be about Percival Lowell's personality, the actual fact is that world astronomy is in his debt.
Percival Lowell could have done anything, or he could have done nothing. Instead, he chose to found a little observatory on the edge of Western civilization, an outpost of American astronomy just south of the Grand Canyon. Indians arrived in this region 12,000 years ago. Dinosaurs walked the land 200 million years ago. Here, our molten planet began to cool and harden into rock some 2 billion years ago. The Grand Canyon is a grand place to contemplate ancient events. You can see back across the millennia by looking down at layers of rock, or by looking up. Stargazing, reading time in space. A supernova exploded in this part of the night sky 11 million years ago. Since that time, the energy wave, in the form of light, has been hurtling towards Earth. 11 million light years. A lot has happened between then and now. (1993J), like other recent supernovas, provides a burst of new information about the makeup of the universe to Lowell astronomers.
This is the image of the supernova we just got. Type 2 supernovae responsible for the chemical enrichment of the galaxy, the sort of star stuff that we're all made of.
Star stuff, black holes, infinity, revealed through these wonderful instruments. Telescopes. The basic telescope hasn't changed much over the decades. What has changed is the eye looking through it. The human eye was replaced by more sensitive photographic plates. Now there is the digital chip, 100 times more sensitive still, capable of receiving a staggering amount of data. In spite of such innovation, basic questions about the universe still remain, the same questions Percival Lowell asked. How big is it? How old is it? What is it made of? Is there life out there? A century after Lowell came west, staff astronomers like John Holtzman still gaze up into the night, their minds engaged in what Lowell called far wanderings.
It's actually kind of interesting question to ask, what's the farthest thing you could see, because astronomy is sort of peculiar in that respect, because since the distances are so vast and since the light does not reach us instantaneously, as you look further and further away, you're looking further and further back in time. So really astronomy is kind of the cool situation where you don't have to infer from what you see at the present time what things were like long ago. You can actually look and see long ago if you look far and farther away.
The most distant and oldest view of the universe yet is this computer-enhanced image of microwave energy taken by a satellite. The microwave spectrum gives astronomers a view of events not millions, but billions of years in the past.
In the microwave sky, you're looking back to the universe that existed very long ago, and it was much smoother, and there were just very tiny lumps in the matter distribution, which by our current theories, we think those lumps grew by gravity to form into the galaxies and clusters that we see today.
Will we eventually be able to see the actual birth of the universe?
Close to the beginning, not quite at the beginning, but close to the beginning. At the very early universe, the universe was opaque, so you can't see back to the beginning because you can't see through the early universe.
Before astronomers can confront the beginning, they must first devise ways to see more clearly up through our own thick atmosphere. Twinkle, twinkle, little star may be fine for children, but the thick blanket of turbulent air that causes the twinkling makes precise seeing all but impossible. That might change soon.
I'm reflecting the light back into this part of the system here.
The Observatory is building a new version of an old favorite, the most powerful instrument yet for seeing, a giant interferometer. This hybrid telescope is being built at Lowell's second site, a mesa south of Mars Hill, far from the light pollution of Flagstaff. Staff astronomer Nat White.
We'll be able to see the surfaces of the nearby stars. The only star that we've ever seen the surface of in any detail is the sun. How would you like to make a judgment on the whole human race based on looking at one person? For us, that's opening a whole new vista, a whole new range of observations, and a whole new possibility in trying to understand the universe.
Mirrors will be spread across a site twice the size of a football field. These mirrors don't magnify, as do mirrors found in telescopes. Instead, being optically flat, they reflect a true image. Starlight, collected from 6 of these mirrors, will be directed down a complex web of vacuum pipes to a central mirror room. When the beams are combined, as in this laser test, they interfere with each other, creating patterns. With actual starlight streaming through the system, the patterns will yield precise information about stars hundreds of light years away. To achieve such precision, the interferometer has to be steady, rock steady.
We're standing on about 50 feet of solid basalt, 8 million years old, and on top of that we've poured over 900 cubic yards of concrete, and the object is stability of our mirrors. When the instrument is all together and the mirrors are on, we'll be able to measure the Earth's surface rise and fall as the moon passes overhead. And that amount of motion would be of the order of some small fraction of a human hair.
When completed, The Lowell interferometer will be a generation beyond the Hubble Space Telescope. Construction is being funded by the Navy. They will use it to refine star charts and improve navigation. Observatory astronomers will have many uses for their new device. One of the first will be an attempt to detect new planetary systems.
The photons coming through these mirrors could carry the information that there is another solar system out there, another planetary system around a distant star.
Such a discovery would be a big step towards Percival Lowell's dream, the confirmation of intelligent life out there. During Lowell's stays in Arizona, he lived in a house of his own design on Mars Hill, nicknamed the Baronial Mansion.
Please see that the wildflowers on Mars Hill are never picked. Put up notices.
At Christmas, he put on a beard and costume, playing Santa Claus for the pioneers, scientific and otherwise, who had come to live on the Arizona frontier. Percival Lowell was almost 40 when he built his observatory. But the night skies had fascinated him since he was 3 years old.
Consciously, I came into this world with a comet. Donati's comet of 1858 being my earliest recollection. And I can see yet a small boy halfway up a turning staircase, gazing with all his soul into the evening sky where that stranger stood.
As the boy grew, so did his inquisitiveness. Still, astronomy remained a hobby. Not until he was in his 30s did Lowell become truly focused on the planets and on extraterrestrial life.
That we are the only part of the cosmos possessing what we are pleased to call a mind is so Earth-centered a supposition that it recalls the other Earth-centered view once so devoutly held, that our little globe was the point about which the whole company of heaven was good enough to turn.
Robert Millis is the observatory's director.
There is absolutely no question that Percival Lowell founded the Lowell Observatory to pursue his ideas about the possibility of intelligent life on Mars.
The telescope presents us with perhaps the most startling discovery of modern times, the so-called canals of Mars. If, therefore, the planet possesses inhabitants, there is but one course open to them to support life: irrigation, and upon as vast a scale as possible.
Lowell had read the works of an Italian astronomer who thought he had seen web-like lines on Mars' surface. Giovanni Schiaparelli called them canali, which in Italian means grooves or lines. Percival Lowell became convinced they actually were canals.
He went into the investigation believing that the lines were there, and given that predisposition, he began to see them. And over time, he saw more of them.
And the more Lowell saw, the more sure he became that they had been built by intelligent beings. Darwin's profound new theory of evolution dominated thought at the turn of the century, and Lowell saw no reason why life wouldn't have evolved on other planets. In fact, he assumed it to be inevitable. And thus began the myth of life on Mars.
Given that he met with skepticism from the astronomical community and a fair amount of sensationalism from the popular press, Percival Lowell sort of took his case to the people. He wrote a number of books that were quite popular.
The press had a field day. Newspaper artists used gallons of ink, drawing wildly imaginative visions of life on Mars. And the public couldn't get enough of it. Not until 1976, when the Viking lander touched down on Mars, was Percival Lowell's theory conclusively disproven.
Even the Martian canal business, where he was dead wrong, had some most interesting consequences. One consequence was that when Lowell gave a set of lectures at MIT, on the canals, there was a teenage boy from Worcester, Massachusetts, who attended. His name was Robert Goddard. And that set of lectures moved Goddard to decide that he would devise a means of going to Mars. And he turned out to be the inventor of the liquid fuel rocket. And in fact, the spacecraft that observe Mars today are the direct descendants of what Percival Lowell did via Robert Goddard.
The public interest in life on Mars soon waned. The controversy left a stigma on the observatory and clouded Lowell's reputation in astronomy. Perhaps in an effort to overcome this perception, he pushed his staff to continue with other research. At that time, it was a common belief that our Milky Way galaxy was the sum total of the universe. What were, in fact, other galaxies were thought at the turn of the century to be young solar systems. Lowell assigned one of his staff, Vesto Melvin Slifer, to study the spiral shapes with a spectrograph, an instrument that uses a prism to break up light from stars and reveal their chemical makeup. The spectral light was very faint, and that meant long exposures, sometimes over several consecutive nights. But Slifer was a patient man.
He would sit there in the dome, in the dark, in the cold, all night long, carefully guiding the telescope to stay exactly on the object he was interested in.
It was miserable, tedious work.
The outcome was that for many of these objects, he discovered the totally unexpected result that the spectral lines were nowhere near where they should have been in the spectrum, but in fact were shifted tremendously to the red. Well, it was ultimately realized that these shifts were due to the fact that these objects were fleeing away from us.
This amazing finding, called the red shift, was to have far-reaching results. Astronomer Edwin Hubble combined V.M. Slifer's spectral discovery with his own research and came up with a startling conclusion. The whole universe was expanding. Later, that concept would fundamentally change the way we perceive the universe by leading to the Big Bang theory. The Lowell Observatory's early role in the Big Bang theory received little notice at the time. It was another discovery that brought world attention to Mars Hill, the search for Planet X. Percival Lowell had spent several years analyzing the orbits of the outer planets. He thought he detected irregularities that might indicate a ninth planet even farther out. Finding Planet X became Lowell's second great obsession. He organized a search that would last 25 years, a search he would not live to see completed. The obsession came to be shared by a young man named Clyde Tombaugh, hired by the observatory in 1929. Though Tombaugh left Lowell 50 years ago, time has not dimmed his memories of a seemingly endless search, scanning, literally, billions and billions of stars. He worked from photographs, black dots against white, negative star images on glass plates.
You get cold, you get numb. There's a lot of perseverance, because this gets brutally monotonous.
Tombaugh spent over 7,000 hours searching for a distant planet and other objects at this machine, a Zeiss blink comparator. It enabled the operator to flip the view between two star plates taken months or years apart. If anything appeared to move, Tombaugh would repeat the blink. It might be an asteroid, or a comet, or lint, or an undiscovered planet.
Toward the late night, about the only thing you get was the station in Mexico. So I listen to a lot of Mexican music. Give you something to think about and listen to. Just sitting there looking at it, that gets mighty monotonous hour by hour.
Tombaugh had been raised on a farm in Kansas where he built his own telescope at the age of 12. He still uses it in his backyard.
This is an old cream separator mount for my pedestal. And this is a puller axis. Here's a small shaft off of my dad's old 1910 Buick. I was 7 miles away from a small town. I had no light pollution whatever. Astronomy was enlarging my horizon, realizing other worlds out there, you see.
Tombaugh drew pictures of the planets and on a whim sent them off to the Lowell Observatory. But couldn't anyone have copied planets out of a book?
The planets are never exactly the same twice, and if you copied them from some previous drawing, they'd find it out. And then you'd be accused of stealing. Now you can't fudge a planet.
Clyde Tombaugh was lucky. His drawings arrived about the same time that the observatory had decided to redouble its efforts to find Planet X.
I saw well and I drew accurately. They were impressed, so they offered me a job.
At Lowell, Tombaugh dove into the task, shooting new star plates at night and blinking the plates during the day. Then, on February 18th, 1930, at 4 p.m., Clyde spotted a faint flicker. A speck had moved as he blinked between the two plates.
Now he got the right place about near where the star is, and it turns in there it was. Exactly what I expected to see. I knew instantly it was far beyond the orbit of Neptune. I knew it instantly.
What to name this new discovery? Such names as Apollo, Bacchus, and Zeus were considered. At one point, someone suggested naming it after Clyde. 2 months later, it was settled. The new planet would be named Pluto. The first 2 letters were P-L, as in Percival Lowell. But Percival Lowell missed the world attention and renown that the discovery of Pluto finally brought to his observatory. He had died suddenly of a stroke in 1916. Lowell the astronomer was buried not in Boston, but here on the Arizona hilltop where his dreams had led him.
Withdrawn from contact, the astronomer is much raised above human prejudice and limitation. To sally forth on a winter's night with the frosty stars for mute companionship is almost to forget oneself a man for the solemn awe of one's surroundings, a fitting portal to another world.
80 years after Percival Lowell's death, the goals of astronomy have not changed a great deal. What has changed are the tools. Percival Lowell, and after him, Clyde Tombaugh, did things the hard way.
I don't think anyone would probably dedicate their lives the way that Clyde did to scanning plates manually by eye. We've got a lot more powerful tools at our disposal, namely fast computers and digital detectors.
Like Tombaugh, Lowell astronomer Mark Bowie is fixated on Pluto.
Oh, I've been doing Pluto since the first years in graduate school. At that time, very little was known about it, and it looked like an interesting project. And as soon as I started working with it, it just completely absorbed all of my waking thoughts and some of my non-waking ones as well.
The planet remains a mystery. In spite of the recent advances in telescope technology, Pluto has never been resolved as anything more than a dim point of light. So how was Mark Bowie able to create a map of Pluto's surface? His clever techniques reveal a lot about the way astronomy is conducted today, by squeezing maximum information from the most meager data. Bowie and his associates began not by trying to capture an image of the distant planet. That was impossible, as it's only a point of light. But they could measure and record the changing intensity of that light as Pluto was eclipsed by its satellite moon Charon, and Charon, accordingly, was eclipsed by Pluto.
Every 3.5 days, either the planet would pass in front of the satellite or the satellite would pass in front of the planet, and blocking portions of the surface from view.
For 6 years, Bowie's team measured the variations in light, then created this computer rendering of the alternating eclipses. As Pluto and Charon alternately obscured each other, changes in the reflected light patterns created a kind of scan, revealing information about surface characteristics of the two bodies.
By collecting all of these scans across Pluto, we can put it into the computer and generate maps.
The map, as incredible as it is, only shows the light and dark areas on Pluto and Charon, but it will have to do until a space probe can be launched.
I think we're entering in a new era, well, at least I hope we are in this country, of saying, you know, we should be doing exploration because we want to do exploration, not because we're trying to beat somebody. You know, it's not a strategic thing, it's just, it's a search for knowledge.
How big is the universe? How old is it? Does it contain other life? Does anything out there threaten us? The answer to that last question is yes. When comet Shoemaker-Levy 9 slammed into Jupiter, millions of people got a preview of what could happen to Earth.
If you can capture the flash of the initial entry meteor, that was one way we could determine the actual moment of entry into the atmosphere. Jupiter is telling us, in my view...
Gene Shoemaker's wife, Carolyn, was the first on the team to spot the strange comet, more than a year before the final impact. Carolyn holds the world's record for discovering new comets, and she only started looking at age 53.
The first feeling I had is a feeling that I get with every comet. I get a real high. It's a real thrill of joy. Here's something that no one else has seen.
It surprised the Shoemakers and their colleagues, this string of pearls comet. But there would be bigger surprises. For instance, the orbit. Comets usually swing around our sun.
That was a complete surprise. It's the first time ever a comet has been discovered in orbit around a planet. So that was surprise number 2. And finally, about 2 months later, then it became evident that it might hit Jupiter. And so that was surprise number 3.
This will be for our school district so that all the kids can see it.
Surprise number 4. The Shoemakers were instant celebrities.
It's not just for me.
You know, if this happened on Earth, this wouldn't, you know, wipe out dinosaurs.
As the comet chunks continued to blow holes bigger than the Earth in Jupiter's atmosphere, people began to wonder about our own planet. What would happen if a comet fell on us?
And something like that hitting the Earth is getting up into the range that it would produce a global catastrophe. A very potential mass extinction of species on the Earth, so it would be really bad.
The Shoemakers have joined a Lowell Observatory project investigating this very threat. They're searching for dangerous asteroids and comets that might be headed our way. This steel pillar will anchor a telescope for a pilot project that could save the lives of 5.6 billion of us. the entire human race. Lowell astronomer Ted Bowl is the principal investigator.
For the first time in the development of society, we are faced with a situation, a threat, if you wish, from outer space that we can do something about.
It is now a generally accepted theory that the age of the dinosaurs ended abruptly with the cataclysmic impact of an asteroid 10 miles in diameter. So Chicken Little may have been right after all. Some astronomers speculate an even larger collision tore off a chunk which became our moon. Compared to the moon and most other bodies in the solar system, the Earth shows relatively few impact sites. There are two reasons. One, most fall into our vast oceans, and two, erosion. One of the few we can see is 35 miles east of the Lowell Observatory.
In the long course of history, many craters of this size must have appeared on Earth and then been eroded away by weathering and the wind and the rain. A crater of this size, caused by a body maybe 100 feet across, occurs on Earth once every 10 to 100,000 years.
This crater was created some 50,000 years ago by a meteorite of solid metal traveling at 34,000 miles per hour.
It was equivalent of something like a detonation of a 20 megaton nuclear device. A very large explosion indeed.
$3 to 4 billion years ago, our young solar system was a war zone of swirling debris. New craters appeared frequently on planets and their moons. Now that debris has settled down, forming a ring that orbits the Sun between Mars and Jupiter. This ring is the main asteroid belt. If we, in a spaceship, leave Jupiter and its moons and travel 250 million miles away to the main asteroid belt, we will still be under the gravitational influence of the Great Red Planet. So are the asteroids. Most of these, 99.9% of them, are locked in eternal orbit around the Sun and pose no threat to us. But there are a few far wanderers, rogues that are not harmless and whose erratic behavior could prove to be catastrophic.
And these rogue asteroids that come near the Earth are driven into near-Earth space by the immense gravitational tug of Jupiter.
Rogue asteroids move into their own elliptical orbits, which repeatedly cross the path of our own planet. Over the next million years, or 100,000 years, or even the next few centuries, there will be a series of near misses. But eventually, there will be a final rendezvous.
Much of the material near the explosion would be vaporized and thrown out from the Earth's surface. When it hit the ground, it would burn everything that it touched, and so forest fires would get set off all over the Earth. There is an additional huge amount of dust from the explosion of the impacting asteroid, so the sun's light would go out at least for several months, and some people think for some years. So it would be blacker than the darkest night that we can experience.
Fortunately for us, impacts of that kind probably occur not more than once every 100 million years. And so the probability of us experiencing such an impact is very small indeed. But our civilization could also be severely stressed by much smaller events.
Almost any size asteroid is a potential killer. The Arizona crater was caused by an object the size of a commercial airliner, but it would have killed everybody within a 20-mile radius. Finding rogue asteroids is no easy task.
Hey, there's something. That's interesting.
For the time being, Lowell astronomers use labor-intensive scanning systems. These will soon be replaced by a computer version of Clyde Tombaugh and his blinking machine, an early warning system that continuously compares one electronic snapshot with the next, looking for anomalies.
And we will scan the sky quite quickly, so we'll cover an area like this in just a few minutes.
What can be done if they actually find a lethal asteroid hurtling our way? One suggestion has been made: fire off a massive nuclear warhead. An iffy proposition, at best.
To deviate an asteroid in its orbit is a difficult technological thing to do. The way you would do that is to set off a nuclear device somewhere near the asteroid's surface. Now, you don't want to set off such a device at the asteroid's surface, because that would almost certainly cause the asteroid to fragment, and being hit by a very large number of fragments might actually be worse than being hit by one single body. So that is a job for nuclear scientists, and as you can imagine, it raises all kinds of possible political and sociological problems.
Problems that are beyond the scope of the Lowell Observatory. Here the concerns are astral, not earthly. That is what Percival Lowell intended, and that is the way it remains.
Astronomy now demands bodily abstraction of its devotee. To see into the beyond requires purity, and the securing of it makes the astronomer perforce a hermit from his kind. He must abandon cities and forego plains. Only in the places raised above and aloof from men can he profitably pursue his search.
Percival Lowell was a visionary, a brilliant mathematician with a soaring imagination, a frontiersman. He left a permanent stamp on modern astronomy. It is called the Lowell Observatory. The people at Lowell today continue to search the night skies, reaching beyond what we know. Stargazers, inspired by the man from Massachusetts with a dream.
You just need to be curious about what's going on out there. It's probably not going to directly impact your life in any revolutionary way, but it's interesting. Curiosity is what motivates a lot of us to live our lives, and it's certainly a worthwhile endeavor in and of itself.
There's a beautiful poem that's written by a colleague of mine, and one of the thrusts of this poem was that, yes, men may go to the moon, may go to Mars, and we'll be exploring, but they'll find the footprints of our minds there before we get there. We're the real pioneers in trying to figure these places out, and it's more of a mental journey, but it's a journey nonetheless. And that's what drives us from day to day.
We are actually the progeny of comets. Comets delivered the water, the carbon, the nitrogen, the things out of which living organisms are formed, and provided the watery environment in which life could evolve. So when you see that comet out there in the sky, you can say, "Hi, Grandpa," or "Hi, cousin."
Imagination is as vital to any advance in science as learning and precision are essential for starting points. Let me warn you to beware of two opposite errors: of letting your imagination soar unballasted by fact, but on the other hand, of shackling it so solidly that it loses all incentive to rise.